Welcome back. This is a big one and one of my favorites. This really shows the power of functional programming, which up until now has been a little bit confusing. It's been a lot of functions, a lot of pure functions. But it's hard to see the use in what we've learned. We've just learned a bunch of terminology, but it hasn't really made us a better programmer. Starting in this video, we're going to start to uncover some of these pieces so that when we work on our final exercise, we understand how powerful this can be. And compose is definitely the most powerful concept, in my opinion at least. Composing or composition is the idea that any sort of data transformation that we do should be obvious. It's kind of like a conveyor belt, right? In a factory, we have data that gets processed by a function that outputs some sort of data, and that data gets processed by another function that outputs that data in a new form, and so on and so forth. Composability is a system design principle that deals with this relationship of components, how we can compose different components of a factory that works on, let's say, a conveyor belt. And a highly composable system provides components that can be selected and assembled in various combinations. Just like an assembly line, we're moving this machine here, this machine here. It's easy to move pieces around to get the desired output based on the user's specific requirements. Let's write some code to see what I mean. And I'm giving you a bit of a warning. This gets a little complicated at first. You might need a few minutes on your own after this video to code this along and figure out exactly what happens. But trust me, initially it's going to look hard. With time, this will become easier and easier. Let's say I want to do something using functional programming. So we want to keep all our functions pure. And we want to do something interesting. We want to do two things at a time. We want to have a number like minus 50 that, gets multiplied by 3. And then we also want to take the absolute of. That means we want a number that's always positive. So we also want to make sure that we remove any negative sign from it. We want to do two things, two functions. How can we compose them together, like an assembly line at a factory? Well, I want to have a function that I'm going to call multiply by 3 and absolute. All right, not the best name in the world, but at least it shows that we're doing multiple things. And I want to do that operation that I told you about. But in order for me to do that, I need to compose these two pieces of functionality. How can we do that? Well, in functional programming, you can use something called compose. Now, compose doesn't exist in JavaScript. However, it's so common that there are a ton of libraries that actually let you use compose. For example, one of the best libraries when it comes to JavaScript and functional programming is Ramda. And Ramda, as you can see, comes with compose. And we can use compose like this, r.compose. And we can pass it in functions, just like an assembly line, to operate on data. But for now, I don't want to use any library. I want to build our own. I want to build a compose function that allows us to multiply by 3, and then also, let's say, take absolute, which means take that absolute number and make sure that there's no negative signs at all. Or you know what? Let's say make positive, because that's what we want. So I want a compose function that, when given a number, is going to multiply by 3 and make positive. How can we do this? Well, let's define our own compose function. And this compose function is going to take, the two functions. So let's call it, and this is f and g. And f and g is going to return another function, and this function is going to receive the data. So whatever we want to multiply by 3 and absolute, that number, let's say in our example, we want to be able to call multiply by 3 and absolute minus 50. So minus 50 is going to be the data. Now in here, the compose is going to accept f and g, which is multiply by 3 and make positive, which is going to return a function right here that takes data. And this data, well, what are we going to do with it? First, I want to take this data over here, which is minus 50, and I want to first, well, apply the make positive. So I'm going to say g is going to call data. And then after that gets evaluated, I want to multiply by 3. Well, again, functions are first-class citizens. And this, when that gets done, I want you to call f, which in our case is multiply by 3. I hope that makes sense. If not, just play back this video and see if you follow step by step. Now, if I run this, I get an error, right? Because multiply by 3 and make positive is not really a thing. So let's make those as well. Let's make multiply by 3. And you see here that I'm just creating pure functions here. Multiply by 3 is going to take a number, and it's going to, well, multiply that by 3. Nice and simple. And then make positive is going to take, once again, a number, and we're going to use the built-in math.abs, which does exactly that. Turns a number into the absolute number, which again, that means removing the minus. So now if I run this, I get 150 because 50 multiplied by 3 is 150, and we make that an absolute number, which turns it into, well, we remove the negative. How cool is that? Using compose, we've created our little assembly line where we can compose different functions together. And that's what compose is. Remember the definition. Composability is a system design principle that deals with the relationship between components. These are the components that can be selected and assembled in various combinations. I can move this around so that multiply by 3 is here and make positive is here, so that the order of operation changes. Just like moving little machinery around an assembly line. And I hope you see the power in compose here, because now we can compose functions, build them together to add extra functionality, to create that data flow where we take a piece of data, we take it through all these functions, and then finally we have some sort of data that gets outputted. Because all those functions are pure, and all those functions, well, are composable. Now, when it comes to compose, that's one of the most common functions that you're going to see in a programming language or a programming paradigm. Like I said, Lambda, well, it definitely has compose. And most of the time, if you're using functional programming concepts, well, you're definitely using compose. But there's also another thing called pipe, which is actually not that difficult. Pipe is essentially the same thing, except instead of going from right to left, it goes left to right. Let me show you what I mean. If instead of compose, we want to create pipe, well, pipe is simply the order will be different. So instead of G over here, we just swap these around. So that now with pipe, the operations are different. F, gets run first over the data. So that's the first parameter that we give in compose. So that means multiply by 3 gets run first. And then G gets run over that data. So make positive gets run first. Now, a better way for me to demonstrate this to you is like this. Imagine if we had a function 1 that takes as a parameter a function. And that function is function 2 that itself takes a function, which is function 3, and that itself takes 50. Now, I know that's confusing, but with compose and pipe, this is what we can do. We can do compose function 1, then function 2, then function 3, and then finally we give it the 50 data point. So with compose, what we can do is say, hey, I want you to evaluate this right to left. That is, take the data, then apply function 3 to it. Whatever comes out of that, apply function 2 to it. Whatever comes out of that, apply function 1 to it. Pipe is just the opposite. Pipe says, do function 3 first, then function 1, or 2, then function 1. So if I do 50, these two functions are going to have the exact same output because the order is actually the same. The only difference is that pipe is going to grab 50 and then start off with function 3, just like compose start off with function 3, and then do function 2, then function 1. So it goes left to right. Now I'm only mentioning this here because you'll see these changed interchangeably, and you can use whichever one you prefer for your readability. And I'm also going to use this technique in our final exercise to compose our shopping cart. All right, hopefully this doesn't hurt your brain too much, but I also hope that you see some of the power that comes with it. We've just created these tiny little functions that, as you can see, can be easily tested, are pure, but we're able to compose them together to do something more complex, like multiply by 3 and absolute. Let's take a break, and I'll see you in the next one.